Hi, I'm Gavin Hudson, and for my presentation, I chose the movie Gifted. This movie was directed by Mark Webb and produced in 2017. In the movie, a young girl named Mary Adler impresses her teacher by doing multi-digit multiplication in her head. She does this using the Jacob-Trachtenberg method, which was developed by the Russian mathematician while he was imprisoned in a Nazi concentration camp during World War II. Let's start with some of his general multiplication. So, his general multiplication consists of the sum of products. So, we have the first number, which we're going to represent as A, multiplied by the digit at I, times the second number, which we'll represent as B, multiplied by the digit at n minus I. So once you do this, you'll add them together to get your product. So let's take 54 times 28 to demonstrate this. So what you're going to do first is you'll take this units digit from this second number and multiply it by the units digit from this first number. So 4 times 8 is 32. So you'll take the units digit from your answer and you'll put it as the units digit of the answer of the overall multiplication. Next, you'll take 8 and multiply it by this 5. And you'll take this 2 and multiply it by the units 4. Which, the 5 multiplied by 8 will give you 40. And the 2 multiplied by 4 will give you 8. And you should put a 0 in front of it for later on. So, since we've used this digit, we don't need it anymore. But we need this tens digit and these two units digits, and we're going to add them together. And when we add them together, we'll get 11. And we'll take the units digit from here, and we'll put it up here. And we'll carry this 1 over to the next part of the equation. And now we're done with these, and we just need to do 2 multiplied by 5 to get 10, and you'll add your 4 and these two zeros, and you'll get 5, and you'll put in the hundredths place. And since you're done with all these, you just need to take your 1 and put it in the thousandths place to get your answer. Now that we've done his general multiplication, let's get more specific. Let's look at his 12s. So, first, let's have t equal, and t will be any number in the base of 10. T will equal 10 to the power of n minus 1, cn, plus 10 to the power of n minus 2, cn minus 1. And it'll go on until we eventually get to 10 to the power of 0, c1. Alright, now let r equal, and r will be the product, t multiplied by 12. So the first thing you need to do is you need to write 12 in base 10. So it's going to end up being t times 10 plus 2. And actually, you need to use the distributive property to distribute the t to each of these terms to get 10t plus 2t. Now you need to multiply. So for this 10, it'll become 10n cn plus 10n minus 1 cn minus 1, and it'll go on like something like that till you get 10 1 c1. And then for this 2, it'll just be 2 10n minus 1 cn, and it'll go on just like t up here. Okay. Now that we've done that, we need to put this in the base 10. Put it in base 10, we're going to common factor. And when we do that, we're going to get 10n cn plus 10n minus 1 times 2cn plus cn minus 1. And it's going to go on something like that until we get 10 times 2c2 plus c1 plus 2c1. Okay. So this is the end of our proof, and we should look at the rule. So the rule for multiplying by 12 is you take the digit, you start from the right with the rightmost digit, and you double the digit, and then you add the neighbor. So let's look at an example of this. We'll take 37 times 12. So you'll take the 7, you'll double the 7, and you'll add the neighbor, which there isn't one, because the neighbor's to the right, and you'll get 14. So you'll put your 4 here, and you'll carry your 1 over here to add to the next one, and you'll double your 3, and then you'll add your neighbor, which is 7, and you'll get 14 again. You'll put your 4 here, and you'll put your 1 over here. Now we add a 0 here, so we can keep going, because we still have a neighbor. And you double your 0, which is 0, and then you add your 3, and you get 444, which is, the answer is 444. And that's his method.